All right, Chapter 10, Section 5, using parallel and perpendicular lines. This is this pretty much our culminating section within this chapter based on parallel and perpendicular lines. The main problems that we're going to focus on here are similar to what was introduced in Section 4, this idea of finding the distance between these objects. And so let's just do a little bit of background review, kind of summation of what we've done in Chapter 10. Again, the main difference between parallel and perpendicular lines, as defined throughout this chapter, parallel lines are going to have are never going to intersect on the same plane. Now, anytime you see these little coordinate grids and stuff like that, that's assuming they're on the same plane. Going a little bit deeper, this aspect right here, the idea of equal slopes. This is going to come into play in a later example we'll do in another video attached to this section. But if I gave you the equations, and you're going to see this throughout this section, if I gave you the equations of two parallel lines, you're going to notice that their mx component, their slope component will be matching, equal slopes. And that makes sense from an algebraic standpoint, but particularly when it comes to slope, what makes a line is if in this example, if I have a slope of negative 2/3, that would mean I'd go down to over 3 between any 2 points, and I'd keep going in either direction up to back 3, so on and so forth. And that would define that line. The B part, the y-intercept, just tells me where it crosses this y-axis as an extra feature. But really, it's the slope that defines what makes this line a line. And if I have another line that has the same slope, what I would end up finding, and I've mentioned this a few times in our class, is that between any 2 points, as I followed this down to over 3 slope, I'd never get any closer or any farther away. And that's why they'll never intersect on this plane. So that's what makes lines parallel. Perpendicularity, in contrast, if parallel lines never intersect, perpendicular lines definitely intersect, as we can see here. But more specifically, perpendicularity means that they intersect at a 90-degree angle. And that's very important. That 90-degree angle has all sorts of functions in higher level mathematics and that sort of thing. So perpendicularity becomes a major factor, particularly further down the math progression, math 2, math 3, that sort of thing. For right now, we're just going to talk about like the very foundational aspects of perpendicular lines. But from, again, this equation standpoint, here's where we end up with this term that you've likely heard before in middle school, definitely in my class, is this term negative reciprocal. It's a very fancy math term for basically, and I had you guys write this down in the margin before, please take the time to do so if you haven't already. Negative reciprocal means flip the sign, flip the fraction. Flip the sign, flip the fraction. So if I had a negative slope, a negative 2/1 slope for this line, then I would flip the sign, the negative would become positive, and then flip the fraction, the 2/1 becomes 1/2. That's what we call a reciprocal. And that would give me the exact perpendicular slope to that first line. Because again, it's slope that defines the line, and so two lines being perpendicular or forming a 90-degree angle is going to be dependent on this. Now, this is a very mathematical version of representing it. If I have some slope, I'm going to take the flip the sign version of it. So if it was positive, I make it negative. But if it was negative, I make it positive. Just flip the sign, opposite sign. And then whatever fraction I had, whether it's a whole number or some weird fraction, all I do is I take the reciprocal or flip it. This 1/m type of thing just means that whatever my slope was, I just take that and I flip it over. So 2/1 would become 1/2, that sort of thing. So again, that's just the background information. Hopefully you have that already banked away in your mind as far as how those slopes relate. And because in these examples we're going to be dealing with the coordinate grid, those slopes are, those features about the slope are going to present themselves many times over. All right, so there are only two examples in this section. Again, it's mostly just a culmination of the things we've done so far in this chapter. This video is going to contain the first of those two examples. And we're going to follow this three-step process that I have written down in my margin. I recommend you do the same. Step one will involve finding the equation of a perpendicular line connecting the two objects together. Step 2, we're going to find out where those lines intersect, those two, the perpendicular line and the original line that was given, where do they intersect? In lots of cases that you're going to see in your assignments, it'll be a pretty obvious thing, a nice convenient location that you can just figure out what the coordinate point is by looking at it. But I'll show you how you can use systems of equations to find out when it's not so convenient. And then finally, step 3, now that I have 2 points, I'm just going to find the distance between them using the distance formula. That will be the process we use for both these examples, but this video is going to contain the first one. This is pretty much exactly the same scenario that we had in section 4, where I have some point and then some line that I'm finding the distance between. So let's jump right into the solution on the whiteboard. And we're going to follow that 3-step process. So here's what we start with. We need to find the distance between the point 1, 0, which means right 1, up and down 0. So there's my point that I'm given. And then the given line, y equals negative x plus 3. In some of your big ideas examples, they're going to ask you to actually graph those objects. So just make sure you're practiced with that. If I was asked to graph this line, I might start at the y-intercept, positive 3, up 3. That tells me where I begin. And then the slope is the number that's attached in front of x. This one is a negative 1, technically, even though they didn't bother writing the 1. That's a negative 1 slope, so that would tell me I would go down 1, over 1, down 1, over 1, down 1, over 1. And that's how I can graph that line. In some cases, they'll already give it to you pre-graphed. So we're going to start with that premise right now, just assuming you can graph it. But here, I need to find the distance between this point and this line. And what we've learned in this chapter is that if I'm going to be connecting these two objects, I can connect a line, any line, between this point and this line. And there are an infinite number of ways I could connect them. And if I wanted to find the distance, the shortest distance between this point and this line is going to be a perpendicular line that connects the two. That's what we learned in section 4. And so that's our first step that we're going to work with here. Finding the equation of the perpendicular, that's what that symbol means, the perpendicular line. And so in order to write the equation of a line, I need 2 pieces of information. I need a slope and I need a y-intercept. So let's focus on the slope first. And this goes back to what we had at the beginning of our section 5 notes. It's going to be based on this given line that I have. Now the slope of this given line is negative 1. And that can be pulled out of the equation or just by looking at the graph for rise over run. But the slope of this line, I'll write it here, the slope of this line is negative 1. Now, if I want to find the equation of the perpendicular line connecting these two objects, I'm going to focus on converting this slope to its perpendicular version, the negative reciprocal. And so here's how I would show that work. I start with a given slope, and I'm going to convert it using flip the sign, flip the fraction. Now, if you want, if this is helpful to you, you can, like any whole number is technically over 1. So sometimes this is how I usually started my problems when I was in high school. If I had a whole number, I'd write it as a fraction so I could visually see how I would take a reciprocal. But let's get back to it. So I'm going to flip the sign. I start with a negative. It's going to become positive. You won't need that positive sign after a while, but it can help to write it. And then I'm going to flip the fraction. 1 over 1 becomes 1 over 1 again, and that reduces to just 1. So what's the reciprocal of negative 1? Positive 1. And this would be the slope that I'm going to work with for the equation of my perpendicular line. Great. So now what I need is, now that I have my slope, I need to find out where the y-intercept is. Now, in this case, the actual fastest way to deal with this is just to kind of backtrack. So if I know my slope is positive 1, I can start here at this point and go up 1 over 1, up 1 over 1, so forth. Or I could go down 1, back 1. And I could actually find out my y-intercepts right there at negative 1. There's my y-intercept. Now I can write my equation. The other way to do it is to use point-slope form. Maybe it's not so obvious. Maybe it's not a convenient whole number intersection. So I could use my point-slope form. Y minus y1 equals m times x minus x1. This is the point-slope form of a line. I have the slope. That's going to be my m of my new line. And then for the x1, y1, the coordinate point is actually the coordinate point that I start with, 1, 0, because it has to contain that point. So y1 is 0 in this case. It went up or down 0. So that's going to be y minus 0 there. My slope here is a positive 1. And then x minus x1. x1 is the x element of this coordinate point, and that's a positive 1, like so. Well, that just reduces to y. 1 times x is just x. 1 times a negative 1 is minus 1. There is the equation of my perpendicular line connecting that point to that line. This is the line on which I'm going to measure. So step 1, find the equation of the perpendicular line. How do I do that? Start by finding the slope of my perpendicular line. That's the conversion from the slope of the given line I'm measuring against. Then I can use point slope form to find out, all right, now that I have that slope, that m, now I can plug in the given point that I'm connecting to it into this equation to find out the equation of my perpendicular line. Step 1, done. Step 2, moving down. Step 2 is to find my intersection. I know what line I'm going to be measuring on, but in order to use my distance formula, I need a second coordinate point to measure between the one I was given. And so just scrolling this up a little bit, all this graph is right here is this is now graphing that perpendicular line that we just found the equation for. This is that x minus 1, positive 1 slope, negative 1 y-intercept. This red line represents that perpendicular line connecting the original point to my given line that I had to measure against. So now finding the intersection. In this case, the simplest way to find the intersection is simply by looking at the graph. This is a nice convenient point. This is at the point positive 2, positive 1. So intersection, I could just be done and say, all right, it's at 2, 1. Done. Now I have my second coordinate point. I'm going to use distance formula between 2, 1 and the 1, 0 that I originally was given. So I can move on to step 3 just by visually looking at this. But maybe it's not so convenient. Maybe it's not conveniently on a coordinate point like in this example. So real quick, here is how I can find that intersection. I have two equations. I was given, or I just solved this y equals x minus 1. That's the equation of my perpendicular line. And I also had this given line at the beginning, y equals negative x plus 3. Those are the two lines that are graphed right here. There's my blue line, my given line. There's my perpendicular line. Okay, so this is like chapter 5 in first semester. I have a system of equations. My job is to find their intersection point. I can, since they're both equal to y, I can set these equations equal to each other. I'm going to burn through this pretty quickly. So I have x minus 1 equals the negative x plus 3. I could combine like terms. I could add this x over here, and I'm going to get 2x minus 1 equals positive 3. I could add this one over here. I get 2x equals 4, and in turn, I get x equals 2 after division. That represents the x half of the coordinate point of that intersection, and I can use this value to plug back into either of these equations to find my y. And so that would lead me to y being, so if I plugged 2 into, say, this equation, if x is 2, 2 minus 1 gives me y equals 1. There's my coordinate point, 2, 1, for the intersection. That's the coordinate point that both those lines share. That's a chapter 5 concept from system of equations. This is important because now I have another coordinate point to find the distance between my 1, 0 coordinate point and that coordinate point. And again, what I want to emphasize here is that technically I could have just looked at the graph and found this nice convenient whole number combination. Okay, but now that I have this, I can move on to step 3, and step 3 is to use my distance formula. And this is where I'm going to end this video. I'm going to pick this up in the next video at the beginning of our next example. Distance formula, again, we're going to use this equation. Just to copy this down, distance is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. All right, we'll be using this formula. What two x values and y values are we're going to be using? We're going to be using the point 1, 0 and then 2, 1, the last point that we just discovered. That's what's going to be plugged into here for distance formula to use for our solution.